So I was discussing the rapid hardening cement. I was discussing how do you get the rapid hardening cement, higher strength cement that we achieve by higher C3S content in cement. So the cement is provided with higher C3S content. That would mean the strength, because C3 has to do with the strength. It's the maximum amount of in ordinary Portland cement, the content of C3S is around less than 55%. But here you go with greater than 55%. At times, you can go up till 70% of C3S content in rapid hardening cement so as to achieve higher early strength. So that would mean decreasing the content of other compounds like C3 and C2S. So that would have an effect on the setting of the cement. But so the setting would be a little delayed, but the hardening would be quicker. So, and the other means is by using the fine grinding of cement. So it's taken care that you at least get 45 microns of cement for rapid hardening cement. So when you have a very fine cement, that would mean uh, this 45 microns of cement would be around 450 to 600 meters square per kg of the surface area. I discussed the last time that you measure the fineness of cement by surface area through the technique is known as Blaine's experiment. It's the Blaine's technique of determining the surface area of cement. In case of ordinary Portland cement, the fineness of cement is around 300 to 450, not 450, 400 meters square per kg surface area. In case of ordinary Portland cement, so in case of rapid hardening cement, you would have a greater surface area, finer cement, and that would mean a lot of cement is available for hydration, and so the hydration would be happening quickly. Overall strength, जो overall strength है उस पर कोई असर नहीं पड़ता है. Overall strength remains same. So, for example, if you had the strength being achieved in ordinary Portland cement in 28 days, so if this was 28 days here, and the particular strength was being achieved here, any particular strength was being achieved here. Now, in this case, in case of the rapid hardening cement, the same amount of strength would be achieved much more quickly before the particular time. That's somewhere here. You are getting the same amount of strength that even before 28 days. For example, at 21 days, it's being achieved. So rapid hardening cement is an early strength cement, but the overall strength then remains constant after this. So this then tends to become a constant curve. So the overall strength there is no appreciable effect on the overall strength. It's just that now, where is the application of this? ये कहाँ पर use होगा? What's the application of this rapid hardening cement? Use कहाँ होगा? Application क्या है? जहाँ पर हमें फॉर्मवर्क जल्दी निकालना है, जैसे कि स्लैब मैंने 28 days तक कास्ट करके रखी है. I do not want it to keep at for 28 days. I just want to remove the formwork after 21 days. So I will be using such type of cement. But this sort of cement is not readily available in the market. You just have to manufacture it on order. This is not available readily in the market. because its applications are there, but not a, a lot of applications. Yes, there are applications in certain projects जहां पर वहां पर मैन्युफैक्चरिंग उसके लिए अलग स्पेशली की जाती है इस सीमेंट की. Then you have another type of cement, that's special, very rapid hardening cement. This is special, very rapid hardening. So this is specially made, very rapid. So it will be the strength achieved will be even before the rapid hardening cement की strength achieve हो रही थी, उससे पहले ही इसकी strength है. So it's ultra early strength cement, also known as by this term, ultra early strength cement. This is the another name for such sort of cement. Now here, the fineness of this cement, you have even higher fineness, 700 to 900 meters square सरफेस एरिया होगा सीमेंट पार्टिकल्स का. अगर मैं उन सबको कंबाइन करूंगा पर केजी ऑफ दैट सीमेंट टेकन फ्रॉम द ब्लेंस मेथड, it was 450 to 600 here in case of rapid hardening, 300 to 400 in case of OPC. Here it's even finer, 700 to 900. But this fine, which is even less than 45 microns cement, there you need to then add gypsum, because otherwise I've already discussed this, that the finer the cement, so the combination would involve the production of a lot of heat, and during the clinkering process the cement could actually not combine easily. So gypsum has to be added in a greater quantity. That's 4% of the gypsum is added here during the clinkering process while the production of cement is being done. So this special very rapid hardening cement, it has got C3S composition of around 60%. So that resembles with the rapid hardening cement, and C2S composition of around 10%. Again resembling with the rapid hardening cement. But the only difference here is that you are making the cement much more finer. For that, you have to add the gypsum content. So what is the setting time that you get for such sort of cement? Initial set is, it actually begins to increase because the C3A content has decreased. जब C3S बढ़ जाएगा तो C3A content decrease होगा. अब जब C3A content decrease होगा तो that aids in early setting. So the initial time of setting has increased to 70 minutes, and the final time of setting has increased to 95 minutes. So this is actually not increased, this is decreased. The final setting time has decreased. So the hardening is achieved quickly after the initial setting has progressed. So whereas in the case of OPC, the final setting time could go even up till 10 hours. That's 600 minutes. So why is the application? What is the use of this sort of cement? A very early setting. So it's actually used in pre-stressed structures, concrete structures. What is a pre-stressed concrete structure? Which are actually cast in the pre-stressing mode is where you are actually applying certain forms of stressing through steel. It's very difficult to make you understand at this moment, but just remember it's a pre-stressed structure, and you can check the figures of the pre-stressed structure at this stage. It's not possible to explain because it deals with a lot of other things related to the analysis and the design of the structures. So that's the application of this form of cement. Next comes the, am I audible to everybody?
Yes, sir.
So any questions up to this point from anyone? Next comes the low heat Portland cement. Now, what is again the name? Low heat. So the production of heat here in this form of cement is less. So the production of cement heat here is less. So why do we want that the production of this heat should be less? For example, in dams, dams are huge structures. This is a dam structure, for example. This is a huge structure. The height of this dam is easily could go to 100 meters. 100 meters is 300 plus 330 plus feet. So that is a huge structure. Now, this dam structure would have an appreciable amount of thickness. It would have 10, 12 meters of thickness. That's around 40 feet thickness of the dam. So this is all made up of concrete. This is all made up of concrete. This dam structure is all made up of concrete. This huge amount of concrete is poured. So how much amount of concrete would be poured if this was 10 meter, the thickness of this dam, the width of the dam being around, say, 40 meters, the height being 100 meters. Now come to this, it's 100 into 10 is 1000, 1000 into 40 is around 40,000 meter cube of concrete. 40,000 meter cube of concrete. Each meter cube of concrete produces, you go for that, you decrease the content of C3A. That is decreased. So it's in all the gravity dams, you use this C3A low heat Portland cement, where the C3A content is decreased. The initial heat of hydration, which is quite rapid initially, that is decreased. So that would mean you also decrease you keep the low content of C2S, such that the strength also is achieved late. So the rapidly hydrating content of C2S and C3S are both conserved. So you are then actually increasing the C3S. So some amount of hardening may be achieved quickly, but decreasing C2S at the same time, the hardening stage would not be such early. So you would have lower or slower development of the strength finally, because C2S is getting decreased. So we deliberately do this. We keep the C2S content low such that the strength is not developed quickly while we are decreasing the content of C3A. So the fineness of the cement is kept very less. Surface area is kept, so the fineness is more. It's 320 meters square per kg. So again, due to this, the early strength development does not happen. We do not want the early strength development. We just want that the setting and the heat of hydration produced is delayed, such that it's the applications, for example, in the mass concreting in dams or other structures where a lot of concreting is to be done, there is not appreciable amount of heat of hydration developed. Any questions related to this? Yes. So then I have another type of cement, that's sulfate resistant cement. Now this is the name itself suggests it's sulfate resistant. What is sulfate attack? I described this last time. When C3A combines with gypsum, you get a compound which is C3 is present within the cement. It combines with gypsum, with calcium chloride. So you get calcium sulfates and H2O. And in the presence of the sulfur or the sulfates, in the presence of them, what do you get? You get calcium aluminates aluminate. And now, what is the property of these calcium aluminates in presence of sulfur? If the sulfates are present, this becomes calcium aluminates, and the volume increase happens, and that is around 120, not 120, it's 227%. Volume increase is happening. So when the volume increase is happening within the cement or within the concrete, that will lead to disintegration. So this will lead to breaking of cement. Because volume increase after hydration has happened, inside if it's happening, so it will lead to cracking and finally disintegration of the cement happening. So there is one more product from which I discussed already. Calcium hydroxide is also produced during the clinkering stage of the cement. So it's also present within the cement. So once that reacts with sulfates, one was this calcium aluminates reacting with sulfates. Other is the calcium hydroxides reacting. So that leads to production of gypsum. So gypsum production at this stage, when the concrete is hardened, so there will be a volume change by 127%. So this volume change again leads to disintegration, and both these processes are known as sulfate attack. It's sulfate attack. Both these processes, these two reactions, they are the sulfate attack. So it both lead to disintegration of the cement. So what do you do actually? So what are the sulfates actually? There are magnesium sulfates, then there are sodium sulfates present from the atmosphere or within the cement or within the water, which react with these chemicals in order to undertake the sulfate attack. So how do you prevent this? How do you make a sulfate resistant cement? Simple, you decrease the content of C3A, you keep low content of C3A, because C3A is reacting with gypsum. So you reduce the content of C3A, so it becomes a sulfate resisting cement. So maximum content of C3A we provide here is 3.5%. How much was it in the OPC? Anyone? How much was the amount of C3A in OPC, ordinary Portland cement, that we discussed last time? At the same time, Fe2O3 is added to cement. Why is it done? Because you have another compound, Al2O3, which needs to be kept constant in the cement. Now, if that is to be kept constant, because you do not want the cement to lose its strength. So Al2O3 is kept constant, but in order to replace the C3A within it, to decrease its composition, you increase the content of Fe2O3. So thereby you get the one product C4AF, जिसमें दोनों हैं AF and, so that mixture has to remain higher. Once C3A decreases, C4AF has to be increased. So ferrous oxides are added and alumina content is kept constant. That proportioning relatively, then C3A content decreases and relatively C4AF is increasing. So this sort of cement, sulfate resistant cement, is not applicable for conditions where chloride attack is happening, where chloride attack is happening. वहां पर processes उल्टे बढ़ जाएंगे क्योंकि वहां पर corrosion of the steel may happen due to the chloride attack. So this may actually aid the less C3A content would actually aid the chloride attack of the concrete, and because we are increasing the amount of ferrous oxide, so iron content is actually increasing, so chloride attack of the ferrous oxides may happen, so that would lead to the corrosion of that will accelerate the corrosion of steel if steel is inside the cement concrete. और वो होता है, ये हर जगह आपने देखा होगा, steel is present within the cement content. So I'll stop here. If anybody has any